Using NCR is equal to n times n minus 1, n minus 2, up until n minus r plus 1 over r factorial to find the binomial coefficient, write down the first four terms of the expansion 3x minus 2y is equal to 8. This gives us a different way for finding the binomial coefficients as opposed to using this formula. Now we can get to from here to here by looking at this. N factorial means n times n minus 1 times n minus 2. Now we're going to add this term here, n minus r plus 1, up to 3 times 2 times 1. Now we'll have a look at this term again in a minute, why it occurs, but there will be a term in here, n minus r plus 1. n minus r factorial is n minus r minus 1, n minus r minus 2, and then it will go down to 3 times 2 times 1. That deals with that bit. We've still got an r factorial, so we'll put that in there. Now this 1 will cancel, this 2 will cancel, the 3 will cancel. Now n minus r minus 2 will be between this one and this one. That will cancel out, and that one as well, and that one as well. But this is n minus r, but this is n minus r plus 1, so this will not cancel out. So all the terms up from there to there will still be there. So we're left with NCR is n minus 1, n minus 2, up to n minus r plus 1 over r factorial. Let's have a look at this one, 5c3. N is 5, c is, r is 3. So we're going to have 5 minus 3, which is 2, plus 1, which is 3. So we're going to have 5 minus 1, and we're going to stop there, 5 minus 2, because that will give me 3, over r factorial, which is 3 factorial. So it gives 5 times 4 times 3 over 3 factorial, which is 3 times 2 times 1. Those cancel out, and we get 10, like back in the video when we did permutation combinations. More importantly, alternative notation is for NC1, that will just be n. We can actually see that one from there, actually. We're just going to have n minus 1 factorial, we'll just leave an n on the top. NC2 will give me n minus 1 over 2 factorial, so r is 2 factorial, and then in this case it will stop when we get to n minus 1. NC3 will give me n minus 1, n minus 2 over 3, very similar to this one here. So notice the last number here is always one more than the number, one less, sorry, than the number here. And NC4 will be n minus 1, n minus 2, n minus 3 over 4 factorial. So this gives me a different way of expanding this. So in general, a plus b to the n will be equal to a to the n plus n a to the n minus 1 times b plus n minus 1 over 2 factorial a to the n minus 2 b squared. So the only thing that's changing here are these, where these coefficients are calculated. n minus 1, n minus 2 over 3 factorial, which is a to the n minus 3, b to the 3, plus n minus 1, n minus 2, n minus 3 over 4 factorial, a to the n minus 4, b to the 4. And this will carry on, and the last but one term will be n, because they're symmetrical if you remember. A, b to the n minus 1, these two powers will be reversed, and the last term will be b to the n. So we can use this idea now to find the first four terms of 3x minus 2y to the 8. So a is 3x, b is minus 2y, n is 8. So the first term will be a to the n, which is 3x to the 8. So we'll be looking up here now. Plus n, which is 8, times 3x to the 1 less before, which is so 3x to the 7. Times, now very important, you put the minus 2y into brackets, and that's to the power of 1, plus n minus 1, so that's 8 minus 1, which gives me 7 over 2 factorial, 3x to the 6 times b, which is minus 2y squared, plus 8 times 7 times 6 is this one here over 3 factorial a, so that's going to be 3x to the 5, 8 minus 3, minus 2y to the 3, and so on. Now we just need to take a calculator and be very careful. 3 to the 8 gives me 6,561, x to the 8. Now we need to do very careful. 8 times 3 to the 7 times minus 2 gives me minus 34,992 x to the 7 y plus, 8 times 7 times 8 times 7 divided by 2 factorial times 3 to the 6 times minus 2 squared gives me 81,648 x to the 6 y squared, and then we do 3 factorial and 6 cancel out because 3 factorial is 6. 8 times 7 times 3 to the 5 minus 2 to the 3, so it would be negative 108,864 x to the 5 y cubed, and that will carry on. This just gives us a different way for finding the binomial coefficients. I hope you've understood, and I thank you very much for watching.